Do we want to go over the quiz or the
the preparation first? Yeah.
Anyone have any questions about it?
Yeah, the preparation. Hold on, let me open it up. Okay. She's done eating now.
That's important.
So, did you have any questions about the
so I did it, but I forgot to, as soon as I was done, we started family night, so I forgot to even pull up the answers.
Oh, okay.
Let me... find the answers. And, yeah, that's right. I thought I had questions with the last part, but then I continued to watch all the movies, and I think I got it, but like I said, I didn't check my answers against the other ones, so I could be completely off. It's happened before. Okay. Now I just gotta find our answers. Okay. So what is the sampling distribution? A set of all samples mean that can occur. Does that make sense?
Yeah.
Okay, got normal on 2. Approximately normal on 3. Why would we just say approximately? Normal.
Yeah, I was wondering about that too. Like, at first I didn't know what he meant. Like on 2 and 3, I like kind of just like described the picture and what it looked like, you know. But when I looked at his answer, I realized that so it's normal for sure if the population is normal. So like kind of like what we did last week, I was saying all these things are normally distributed. If like the population is normally distributed, then the sample means is normally distributed.
Okay.
But if the population is like not normally distributed, like if it's left skewed or right skewed or uniform or whatever, then it's approximately normal if the sample is big enough. That's the central limit theorem or whatever.
Right.
Does that make sense?
Yeah.
Okay.
Yeah, I know what you're talking about. I mean, it's still like computing in my mind, but I know, I remember reading about the central limit theorem. And
yeah, it was difficult for me to like, I was reading it, but it was difficult for me to like put a picture to it and like try, like you said, like compute it in my mind and try to like really understand it.
So I know there's 2 different, there's the not normally distributed and the normally distributed. Is the not normally always approximately?
I think so. Well, not unless the sample means is small. Like in the reading, it said for our class, if the sample means equal 30. To or above 30, then it's going to be approximately normal every time. But if the sample was like 5, then it would reflect the population. It wouldn't be normally distributed or even approximately normally distributed. It would just be like the population would be like right skewed or left skewed, whatever the population was or whatever. Does that make sense?
Okay. So it's approximately normal if it's above 30.
Right.
Right?
Right. I think equal to or above 30. So it could be 30.
Okay.
Yeah.
Okay. Number 4.
Okay, yeah, number 4. How does the shape of the distribution of sample means change when the sample size is increased?
Sample size has been increased. Well, I put it becomes more normal or bell-shaped, but I think that was wrong because I've continued to read and that seems wrong to me now.
I put that the distribution means is more centralized and the standard deviation is less, because that's what I saw in the little graph things that it had me do. But then I read the actual definition of what that was, which was it was showing this central limit theorem or the law of large numbers. I know they're different, but it was basically showing me the law of large numbers where if the sample size gets bigger, then the sample means is closer to the population mean, which I know is kind of confusing. But
so I wrote this down. It says if the standard deviation of the sample mean gets smaller, but this is saying
right.
size increases. The sample size increases, then the standard deviation sample means will decrease. Is that what it's asking?
I think so. I think you have the right thing. Like the standard deviation gets smaller. Maybe.
Is it saying the answer actually says the sampling distribution more closely approaches the normal distribution and the standard deviation decreases. The mean is unchanged.
Yes.
Yeah, and that's right out of the textbook, almost word for word, just a law.
Okay.
Let's
mark that wrong.
If you pull up that, did you look at those graphing things that had you go to where it said click on this link and it showed all these graphs on the textbook? Yeah, in the textbook. It had like
I recall.
Step 1, step 2, step 3, step 4, do all these steps.
Yeah, I did that.
Okay. So if you go to, if you pull that up and you just kind of play with it, if you change the sample number, then you can kind of get what it's talking about. It you can kind of see it, which might help you.
Okay.
Help more sense.
Yeah, I was playing with it, but I didn't really know what I was just pushing buttons and stuff. It wasn't really making sense. But I did what I was told to do. So.
Right. Yeah, it took me a minute to kind of see what it was trying to say.
Okay. Okay, I'll go back to that and study it more. What is the difference between the central limit theorem and the law of large numbers? I put law of large numbers, an increase of sample size, the more accurate, or the central limit theorem. The sampling distribution of the sample mean will be approximately normal if sample size is sufficiently normal. I think I copied that out of the textbook, but I don't know because it really doesn't make sense what I just said.
I think it was mostly right what you said, because I think I have the same thing written down. You said that the central limit theorem would be approximately normal if the sample was approximately normal. Is that what you said?
If the sample size is sufficiently normal.
So I think it should be sufficiently large.
Okay.
Because the larger the sample, then the more it'll reflect a normally distributed sample means. Does that make sense? Like that's the yeah. that's the magic 30 number or whatever. So if your sample is less than 30, then it won't reflect an approximately normal thing. But if it's bigger than 30,
so the 30 is has to do with the central limit theorem.
Yeah.
Applies to that.
Yeah.
I'm gonna just put that in. So
yeah.
I have it for my notes. Okay.
I know it took me a minute to understand all this. A bunch of means and samples. And
yeah, I don't know if I'll ever understand it, but I'm gonna try. When is X normally distributed? if data were drawn from a normal population or if the sample size is sufficiently large.
That's perfect.
Yes. Okay.
Okay, part 2.
I have so I have 7A. I have, let me get it right. Oh, I don't think I did it right. Oh, it says this depends on 5 salaries you drew.
Yeah, you have to go to that website or whatever.
Yeah, so I did it. I got 46,500.
Okay. I got 46,500 you said?
Uh-huh.
I got 47,080. So it's pretty close.
Mine was 44,900.
Really?
Yeah.
But it all falls in that like close range though.
Right. It's pretty low though. I mean, I don't know. I guess it's normal. Whatever.
So this graph illustrates the distribution sample. Okay. I didn't know how to mark it.
I didn't either. I just kind of made a mental note
Okay.
where it was.
Okay. I didn't know if there was a special key how to mark it. I tried, but
So for C, does your sample mean appear to be unusual? Mine, I put mine was not unusual because it kind of fell in that bell, that curve. So it was like right in the middle almost. So I was like, well, mine's probably normal.
right. That's kind of what I said. I said the sample means is aligned with the population mean, the U part PU thing. I don't remember what they call that, but
Right.
looks like a P and a U that married or something and had a baby.
Yeah.
Okay.
Perfect. And then D. This was the part we were supposed to do together. Compare your means.
From 7, 8 to
Between 3 individuals, what do you notice? In practice, you only get to see means from the samples you drew. You do not get to observe it. Okay. But basically I think the point there was basically all of ours was pretty close together.
So would we say they all are normally distributed? Or what should we say? Or they just, is there a technical term for what we just said?
They all are.
I think they're just supposed to show that like when you have more samples, you can get closer to the mean. Like you would only have your sample because you did one experiment, but if there were multiple experiments to compare, that it should all be closer to the mean.
Okay. So we should just say all of them are close to the mean? All of our numbers?
Yeah.
Okay.
Sorry. Guess that's right.
For 8, I got normal.
8, yes, so did I. Did you get normal?
Yep.
Okay. How do you know that the distribution of the sample means has this shape?
Because normal distributions are always normal or bell-shaped.
Right. So, and it's asking about the sample means. So we were told that the population was normally distributed. So that means the sample means, or the sample distribution, is also normal.
Because it was asking in the thing, it says if it's normally distributed, it's always
normal.
Yeah.
Right.
Yeah. Okay. C, I got 529.
Yep, that's what I got too. Basically the same. the mean is the sample mean is the same as the population mean.
Yes. Okay, and what is the standard deviation of the distribution of sample mean score for all such samples? Are we supposed to round that to a certain? I mean, it doesn't say.
It doesn't say. I just looked at the answer key to see.
Oh,
Because the answer key just rounds it to 3 decimal places.
Yeah.
Somewhere it seems like I read that that's kind of what's expected of us if it's not otherwise
Stated.
specified. Is that right?
Yeah.
Okay. Awesome. Okay.
Greens.
Now let's get the quiz pulled up here.
Meeting quiz.
Lesson 6, right?
Yep. Start quiz. I like the first 2 questions. Those are always good.
As long as you did it. If you didn't, then you're like, ugh. Just kidding. I'll come back to this quiz.
Right.
But I did. I miraculously got it done. I thought there's no way I'm going to get it done, but I did. The Lord helped me. Prayed really hard. Okay.
Okay, I'm on question 3.
Okay. Do you want to start us out and read that one?
Cool. Okay, when you are taking a sample size of 5, or n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
What?
It's a lot of stuff.
How the heck are we supposed to know that? Sample size is 5.
Mhm. Which I think important to realize is it's less than 30.
Less than 30, but somewhere we said something. They talked about 5.
Oh, that was probably in the little step-by-step thing. I think we were supposed to change 5
When
to...
the sample mean is normal, it says if a parent population is almost normal, mound shapes are nearly symmetrical, then the sample of n equals 5 will probably be sufficient. But that says that it's right skewed. So it's not sufficient.
Where are you reading that at?
It's in the textbook.
It's in the textbook, and I just write it down because I can never find the textbook where I need it. So I just basically took it out of the textbook and wrote it in my notes. Then it says, if parent population is heavily skewed, then it will require a larger sample size to assure the sample means will be normally distributed. So the sample size of around 30. So this one's talking that it's skewed.
Right.
The 5's not going to be sufficient, but I don't know.
Parent population is almost...
What is the shape of the distribution of mean?
Okay, I see. So it's saying, okay, so ours is not even remotely normal. It's skewed, right?
Well, it's
So,
saying,
like,
it tells us that it's right skewed.
right. And so what you just read in the textbook is saying, therefore, it won't be sufficient. It's not a sufficient number of samples, right?
Right.
Yeah, sample number. And so that means that it won't be normal. So it'll probably be right skewed, right?
That's what I thought, that it'd have to be right skewed because it's not a good amount enough of population samples. Because it's only 5 instead of 30. If it was 30, then it could be normal. But
Right.
since it's only 5.
So how do we
Right.
know if it's skewed right or skewed left?
I think because the parent population is right skewed, so it's going to like kind of trickle down and reflect what the parent population looks like.
Okay.
Does that make sense?
I'll go with you.
Okay.
Okay.
Or at least that's what I saw in the little graph thing.
Oh, yeah, the thing that we were supposed to play with. And okay.
Okay, question 4. When you are taking a sample size of 100, what is the shape of the distribution of means histogram when the parent population is right skewed? Okay, so now we do have a big enough sample that it should reflect the normal distribution.
Okay.
Right.
Because it's over 30.
Right.
Okay. So normal. You agree, Shanna?
Yeah, that's what I got too.
Okay. When you are taking, sorry.
No,
when
go
you
ahead.
are taking a sample size of n equals 5, what is the shape of the distribution of mean histogram when the parent population is normally distributed? So what we read earlier is that 5 is sufficient if it's normally distributed, right?
Yeah.
Yeah.
Okay.
I think anything is sufficient if it's normally distributed. Then I think it, like you said, if it's normal, then it's always going to be normal or whatever.
Okay.
Okay. Question 6. You want to do question 6?
When you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed?
That should be normal too, right?
Right.
Yeah.
Right.
These are a lot easier than I thought they were going to be. Sheesh. Okay.
Okay. Question 7. When would the distribution of means be normally distributed? Choose all correct responses. So I guess you could choose more than one.
Normally.
So
Okay.
yeah, when it's normally distributed. So data are drawn from a population that is normally distributed, and the sample size is small.
I think yes. Because it's normally distributed.
Right. Yeah, I think you're right on that. Data are drawn from a population that is normally distributed, and the sample size is large.
Yeah.
Thanks, and that should be right too. Data are drawn from a population that is right skewed, and the sample size is small.
No.
I don't think so either. And then the last one, data are drawn from a population that is right skewed, and the sample size is large.
Correct. Yes.
Correct. Yes.
Right.
Sweet. Okay. Which of the following gives the best explanation of central limit theorem? Oh my goodness. Okay. If a parent population from which the data are drawn is normally distributed, then the sample mean will follow the normal distribution. For bell-shaped data, approximately 68 of the data will be within. I don't think it's that one.
I don't think so either. That was the last lesson.
Yeah. I think that's just trying to trick us. If the sample size is large, the sample mean will be close to the population mean. We talked about that.
I think that's the law of large numbers.
Or if a sample size is large, the shape of the distribution of sample means will approximately normal.
Yes, I think that's it.
Yeah, I think that's right. Because I have it written down under my central limit theorem.
Okay, cool. Good.
Okay.
Question 9. Santa's turn.
Use the following information to answer the next 4 questions. Let x be a random variable, population mean equals 10, and population standard deviation equals 6. Suppose a sample size of 36 is drawn from this population. What is the mean of the distribution of sample means?
The mean would be 10, right?
Yeah.
Yep. Okay, question 10. What is the standard deviation of the distribution of sample means? So that's when we have to do some math.
So we do 6 over
Right.
the square root of 36.
Yeah, and that makes it easy because 36 is a perfect square. So that's good. Right? So 6 times 6 is 36. So the square root of 36 would be 6.
Yes, you're right, but I'm just going to put it in my calculator.
Double check.
I totally believe you, but I don't understand you. 6 divided by square
You
root.
almost need like one of those math calculators for this class.
Yeah.
You know?
So I have 0.167.
I just got 1.
I
Okay.
just got one.
Let me
Are
see.
you squaring it?
6.
School,
Oh,
you mean take
I did it in the wrong order. See that calculator. You're right. It's 1.
It is
All right.
1? Okay.
Yeah.
I want the calculator to to tell me I'm right too, so, so I can go. Okay.
Ooh, 10. Okay. Regardless of the distribution of the population, if the sample size is large, or magic 30, what would be the shape distribution of the distribution of the sample means? So would it be normal?
Yeah. I think yeah.
Regardless if it's not normally distributed or normally distributed, if it's higher than 30, it should be normal. Is that correct?
Right.
Okay.
Or approximately normal.
Oh, yes. Okay, that's right. There's not an approximate there, right? Okay.
Right. No, so yeah, just normal.
Okay.
Okay, what theorem would justify your response to the last question?
Oh, for heaven's sakes, I don't know.
Should just be the central limit theorem, right?
Yeah, I just looked at the definitions of those two
Mm-hmm.
laws.
Yeah.
Yeah, it should be central limit theorem.
Okay. Where did you look them up, Shannon? Did you look in our textbook or did you find it somewhere else that says it a little bit?
Yeah, they're on the textbook, but they're also on the preparation key. He kind of goes over it on the key.
Yeah, because I looked over it in the textbook, but it was, to me, it didn't make sense. Like, I just kept taking notes, and I was like, okay, this doesn't really mesh for me. Okay, so save that and submit quiz.
Yep. Okay.
Did 100%.
Yeah.
Yahoo! Okay. Did you go on to the homework? I did not, so I can work on that tonight, and then
Good
did you
idea.
guys go on to it?
Yeah, I was working on some of it.
Okay. Once I get my kids to bed, I will work on that, and I might have more questions.
Okay. Yeah, just email or whatever.
Okay. And then tomorrow night, right? 8:30 again?
Yeah.
Yeah, that'll work.
Okay. See you tomorrow. Thanks, guys.
See you, Mindy.
Bye.
You too.